Good morning, guys. Welcome to the final lesson in chapter 7. This has been a pretty good chapter. I've enjoyed it. You guys have been doing pretty well with it, so I'm very happy with that. So today what we're going to do is we're going to analyze and sketch graphs. Okay, so we're going to go through what it is that the lesson is, and then I'll talk a little bit about what your actual assignment's going to be. It's going to be slightly different today than what you have done in the past. So the first thing we're going to do is we're going to analyze graphs. Let's take a look at this graph right here. Notice that there are two labels on here. Now, when I used to teach elementary school, and we would do bar graphs and pictographs and line graphs, one of the things I would do is I wouldn't put any labels on there or any numbers on there, any scale on it. And I would ask them, what information can you learn from it? Because that's one of the biggest things with graphs is it just gives you information without having to look at all the data points. So this one just talks about the distance and the time. So this right here is increasing, all right? So as the distance is increasing, as the time is going up, or as the time is increasing. And you notice it's going up in a straight line, so this is going up at a consistent rate, okay? Then it reaches this spot, and it goes 0 up, 0 down. That is no change, or it remains constant. So basically in that situation, it's just saying as the time's going on, it's not changing the distance whatsoever. And then from this point down, it's decreasing. And again, because it's a straight line, we'd say it's decreasing at a consistent rate, okay? Or at a constant rate. Now, a constant rate and a constant are two different things, okay? So I just don't want you to get too confused with that. So now we're going to look at certain situations and try to analyze what in the world it means. So here we have two graphs. Okay, so describe the change in temperature in each city. So we're going to look at Belfast, Maine, and going up the temperature. So as it goes up, that means the temperature goes up, and down, temperature goes down, and as time. So this says as time is changing or as time is increasing, the temperature is going up. But you notice as it goes up, it starts to go up at a slower rate until it stops going up, and then it starts to go down or decrease. So it increases, but it's not at a constant rate. Stops increasing and then begins to decrease. And then as time goes on, it decreases faster and faster and faster. And how do you know it's going faster and faster and faster? Look at how it's curving. The more it curves, okay, if it was staying constant, it would look something like that. So it continues to go because it's curved at a faster and faster rate. Now let's look at Newport, Oregon. So this one, it starts out at a temperature, and the temperature decreases for a certain amount of time, okay? And then, but it's decreasing at a consistent rate, okay, or at a constant rate. And then it reaches no change whatsoever for some time, and then it increases again. But you notice it increases at a constant rate, but it's not as fast as this one. How do we know it's not as fast? Because it's not as steep. So write an explanation for the decrease in temperature and the increase in temperature in Newport, Oregon. So here's where you got to try to figure out what in the world would do it. So why would it go down so quickly, kind of hover, and then go back up? Well, could be a storm came through. Think about the summertime. Super duper hot, thunderstorm rolls in, temperature drops, rains. It drops and it's raining and raining, and as soon as the sun comes back out, the temperature goes right back up. Okay, and sometimes, especially if it's in the late afternoon, it doesn't quite go up as much. So that's kind of what that situation represents. This one, we won't talk about necessarily all of it, but let's just look at it real quick. It's a pelican. It's the flight of a pelican. So this is the vertical distance compared to the horizontal distance. So you notice it slowly descends as it's traveling horizontal. It's slowly coming down. And all of a sudden, it drops dramatically. Okay. So there's a decrease the entire time, but it changes. So it slowly goes down and it drops down dramatically. And then it slowly begins to continue to descend as the distance increases, as the horizontal distance increases. So why would that happen? Well, maybe he's slowly coming down and maybe he thinks he's going to find something. Because pelicans, they dive into the water to catch fish. So maybe it saw something, or it decided it was going to come down to land in the water. So it kind of had a nice quick drop, and then it slowly came in for a landing. All right, kind of a neat little thing. So the next one we're going to do is we're going to go to Jamboard, because the first couple ones were all about interpreting a graph. Now we're actually going to draw a graph. Okay, so we're going to go to the Jamboard for that one. So a stop subway train gains speed at a constant rate until it reaches its maximum speed. It travels at this rate for a while and then slows down at a constant rate of speed. So the key word there, key things that we want to see are constant. So when you see a constant rate, okay, that means it's linear. So then it travels at this speed, it reaches its maximum speed, so that's where it's going to be no change. It then travels at this speed a while and then slows down at a constant rate. So again, that's going to be linear, coming to a stop at the next station. Sketch a graph that represents the situation. Okay, so if you notice before, when we looked at them, we had the graph, but we have labels over here. So we need to come up with two labels. So what is it going to be? Well, what is it talking about? Speed. So that'll come over here. And what's the other thing? Well, could be distance. Could be time. Okay. Let's call it distance because it's going from one station to the next station. So we'll just call that distance. Again, doesn't really matter which one you do. If it was on a quiz, I probably wouldn't mark you wrong if you put time here. Either one's fine. Okay, so it increases speed at a constant rate until it reaches its maximum speed. So that's going to be a line. Pretend that's a straight line. Okay, it's kind of hard to write with a mouse. Then it goes at a max speed. So this is the max speed. So that's going to be a straight line. Pretend that's straight. And then it's going to slow down at a constant rate of speed, which would be a straight line. Okay. So actually, let me extend this line a little bit. Here we go. And then I'll extend this line a little bit. Okay. So it increased at a constant rate of speed, hit its maximum speed for a bit, and then slowed down at a constant rate of speed. So constant was linear, and then no change there. Okay. Let's look at the next one. A fully charged battery loses its charge at a constant. Okay, there's that constant rate again. So it's going to be linear until it has no charge left. You plug it in, and it fully recharges at a, there's that constant rate again. Then it loses its charge at a constant rate until there's no charge left. Okay, so it's going to be full charge, go down to nothing, go back up to full charge, and then go down to nothing. Okay, so what are our labels going to be? So it seems like it's going to be charge. I think I spelled that right. And then we'll call this one time. Okay. All right. Let me change colors here. So let's call this the top full charge. It's going to go at a constant rate. Now, just because it's a constant rate doesn't mean they all have to be the same angle. Constant rate just means it's a straight line. So let's say it goes down like that. Now it has to go down to nothing, all right, because it says it goes down to no charge. And now it's going to have a constant charge or constant rate back up. I'll have it go up a little bit faster. And there's the full charge. And then it has to go back down to nothing again. And again, it's constant, so it just has to be a straight line. Okay, so when we're drawing them, what you need to have is the two lines. Okay? And then you have to come up with the two labels, whatever it is. And then you have to see, okay, if it's constant rate, it's a straight line. If it's not a constant rate, it's probably curved at somewhat. Well, I don't know how in-depth it's going to be with that. Okay, let's go to the next one. So part of what we do is looking at real life situations. So this is a real life data. Right? This is a real life graph. This is the number of new cases of COVID-19 in New York City since, I guess it's about March 7th. All right. Now you notice it does go up and down a lot. What's interesting is when I was looking at it, you notice it goes 5 talls and 2 shorts, 5 tallers and then 2 shorts, 5 tallers and 2 shorts. What do you think that means? Correct. least I hope you thought it correct. Those are the weekends. And if you actually look at the dates on the bottom, 3/22, which is this date right there, that's a Sunday. 3/15 right there, that's a Sunday. So this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So they just do more tests during the week than they do on the weekends. That's all. So we can actually get a graph from this. Let me see if I can draw it best. So this is something called line of best fit. Okay. So what we can do is look at this, how have the new cases come out. Now, some of these numbers over here are not 100% complete at this point because it takes a few days for the numbers to come out. So they're not always exactly 100% accurate. So the ones we go back, but you can see an overall trend of what's happening. So how did the caseload of COVID-19 happen in New York City? Well, this right here, just so you guys know, this is when we stopped going to school. Our last day was this day right here. Now, I know this is New York City, it's not New Jersey, that's fine. Not a big deal. But that was our last day in school. And if you notice, what happened was it was growing, but it wasn't growing at a constant rate. Okay. This is called an exponential rate, but not really worried about that. But it was growing, but the growth rate was increasing, and it continued to increase, not at a constant rate. Okay. And then here it started to, so it rapidly increased in this period of time for the, from the week after we stopped going to school. And then it hit its peak about 2 weeks later. The increase started to slow a little bit. I mean, although it was a lot, but the amount of increase slowed down. And then after about the second week of April, it started to, beginning of second week of April, it starts to come down and it's decreasing. Okay. Now, is it totally going to flatten out? I don't know. This is probably going to come up a little higher once we get a little more data in. But you can sort of see the increase of it. And this is what the politicians are looking at when they're trying to make decisions about what's going to be open, when things are going to open. They're just analyzing this graph, and the same thing. How much is it increasing? When is it slowing down the increase? When does it start to decrease? The next one is the hospitalization rate. So these are new people who entered the hospital with COVID-19 symptoms. So again, right here, this was the last day of school for us. So you notice two of them actually mirror each other pretty well. It increases and increases, and then it decreases. So it increased rapidly. And this was all the time when people were concerned about getting more ventilators. And then it slowly started, and they kept talking about when are we going to reach what's called the apex. And the apex is this part right here where it goes up and it stops increasing and it then begins to decrease. And, there's always been a lot of talk about, okay, when is it going to descend? How fast is it going to descend? So it increased rapidly, hit the apex. Now what's crazy is this is 1, 2, 3, 4, 5, 6, 7, 8. Now, this is 10 days. This is a week and a half. So when you're in that week and a half, it feels like a long time. And then it really decreased. Now, again, this is not the number of people in the hospital. This is the number of new people going into the hospital. So again, that's a piece of data that they're all looking at. So this whole analyzing of graphs that we're doing today is constantly being used right now to help let us know when we are going to possibly go back. Well, when we go back to school, if we go back to school during the rest of this year. Okay. So your homework today is going to be a little different. It's not going to be in Big Ideas. Although they are Big Ideas questions, it's not going to be in bigideas.com. There is going to be a sheet for you in the classroom section. And in it, there's going to be some graphs, not this complex, but there are going to be some graphs that are similar to things like this. And it's just going to ask you to analyze them. So you're just going to type your answer underneath the picture. So the second thing that you're going to do, okay, is you guys are going to use Jamboard. I believe you guys have Jamboard. Okay. So what you're going to do is I'm going to put in a Jamboard for you with some of the questions on it. And you're going to do just what I did here. Not very complicated. Okay. I'll probably even have it set up with the background in there for you. Okay. So all you have to do is now just be patient and slow. Okay. Do I expect your line to be perfectly straight? No. Do the best you can. You'll be okay. You need to have your label down. Your label. and then whatever it is that you have to do. Okay? And again, get it as straight as you can if it's a constant rate, all that kind of stuff. I will have GoGuardian on with the chat function open. Please reach out if you need any help. All right, bye.